Hi, my name is Dalia Hassan and I'm doing an experiment, I conducted an experiment on the optimal way to purify Human Beta Defensin 2 and Recombinant Spider Silk. My experiment focuses primarily on these two proteins, and which they were both purified through affinity column binding, and they were both dialyzed for 3 days and observed through fluorescence and circular dichroism spectrophotometers to see how pure they were. So recombinant spider silk is a different way of making natural spider silk through protein purification. Spider silk is a lot more malleable and strong than steel or iron, and it's even known to be 3 times tougher than Kevlar. So not only is it as strong as metal, but it's also it can be used for a lot of things. It can be used for like artillery, for armies. It can be used for like machinery. It can also be used in new advances in medicine. Scientists are even trying to find a way to like use spider silk to replace your joints. There was recently an experiment conducted where synthetic spider silk was used to make an artificial leaf. So it's definitely advancing, but spiders are very territorial and they attack each other, so it's very hard to breed them. So instead of just breeding a whole bunch of spiders and making synthetic spider silk and making like natural spider silk, instead scientists are taking the spider silk protein and purifying it to make synthetic spider silk or recombinant spider silk. So that's the first protein, and the second protein is Human Beta Defensin 2, also known as HBD2. And HBD2 is an antimicrobial peptide which fights against gram-negative bacteria, and it is found in our bodies. So usually spider silk was purified, and it's known as 6-mer spider silk, which means that it has 6 repeats. And in this experiment, 15 repeat spider silk was purified using the same process as in the 6-mer, as shown in previous experiments. But what I was doing was I was seeing if the protein was still stable even after purifying it and letting it be 15 repeats. And Human Beta Defensin 2, I changed the purification process by just trying out a different type of buffer to dialyze it in. So my goal was to see if even after changing the methodology, I would still have pure proteins. And for future experimentation, these two proteins could be cross-linked to hopefully make an antimicrobial gel. And HBD2 is good as a model for future proteins that can be binded to silk, because we can go so much further. We can take the silk and we can make not only an antimicrobial gel, we can use it just to make stronger artillery bonded with other proteins. So yeah. We reached the conclusion that this alternative method would work, and we could make 15 repeat silk using the same purification process, and beta defensin would still be pure even after slightly tweaking the methodology. So it turns out that alternative methods of purification do still work, and we can still make pure silk and beta defensin as analyzed through observing their secondary and tertiary structures. Thank you.